Oh, now it's time. We'll talk more later. Okay.
I'll get my presentation up.
Okay, yeah. We are so honored to have Professor Maureen Green here to give the presentation for the International Symposium on Geoheritage and Parks. And he is also the for our journal. Today he will give a very important topic, the UN Sustainable Development Goals and the role of geosciences. I mean, it is a very important topic, and we can know better from this big scope. And I will give a brief introduction about Professor Maureen Green, and so we can start. Okay. Professor Maureen Green is honorary professor at Queen Mary University of London in United Kingdom, and visiting professor at University of Minho, Portugal. Originally a glacier geomorphologist, and he now develops ideas and policies in geodiversity, geoheritage, geoconservation, and geotourism. He is author of 2 editions of Geodiversity, Valuing and Conserving Biotic Nature, published by Wiley Blackwell in 2004 and 2013. Recently, he has worked with others to persuade UNESCO to establish an International Geodiversity Day starting on October 6th. So it was approved last month. I remember November 22nd, right? And we are so happy. This is a really big milestone for the development of geoconservation and geoheritage and geotourism. So we are so good to have him here, and now he will give the presentation. Thank you. It's your floor now.
Okay, thank you. So today I'm going to talk about the UN Sustainable Development Goals and the role that geosciences can play in achieving these. I don't know why. Oh, here we are. Okay. In 2015, the UN Sustainable Development Summit adopted an ambitious list of 17 Sustainable Development Goals and 169 targets, and these were to be achieved by 2030. And the general aims of these Sustainable Development Goals were to end poverty, ensure universal access to basic services such as clean water, food, education, and healthcare, to tackle inequalities, to ensure sustainable consumption of the world's resources, and to promote inclusive economic growth, social development, and environmental protection. So, as I say, these are ambitious targets to achieve within the next decade. I'm having trouble with moving these slides on. Let me try that. Yeah, there we are. So these are the 17 Sustainable Development Goals. They're number 1 is no poverty, going through to 17 partnerships for the goals. And you can see the ones in between on that slide. Now, despite the relevance of geodiversity to achieving many of these goals, the fact is that geology wasn't taken into account in framing them when they were first established. However, a number of studies have demonstrated the links between geodiversity and the Sustainable Development Goals. So things like Earth surface processes, the Earth's materials, and the expertise of geoscientists in attempting to achieve these goals hasn't been taken into account, but is clearly obvious when you think about it. And I'm going to show you now.
Recording in progress.
I'm going to tell you about, I'm going to show you a slide now, which is a poster or a section of a poster from the produced by the Geological Society of London. And here it is. So you've got on this slide various aspects of geology or geoscience. And underneath or beside each title on this slide, you can see a coloured box or a set of coloured squares, which are the Sustainable Development Goals relevant to that particular aspect of geology. So you can see all these aspects of geology have got boxes beside them, indicating that they are linked to the Sustainable Development Goals. And as I've said, there have been a number of studies that have started to talk about the link between the Sustainable Development Goals and the geosciences. And this is a slide from one of those studies, which shows on the left-hand side aspects of the geosciences, and on the right-hand side, how these aspects are relevant to improving the living conditions of society. So the first one, for example, is agrogeology, in other words, agricultural geology, which would include the use of rock and mineral resources to improve agriculture through improving soil fertility and water retention and reducing soil erosion. And then down at the bottom, you've got minerals and rock materials. And the description is the use of geological sciences to identify and develop mineral and rock resources for a variety of uses, such as ores for metal production, limestone for building stone, or glass. So a number of aspects of geology then are relevant to the SDGs. And here's another example, 12 interactions between geology and international development, ranging from top left, access and management of clean water and sanitation, through to bottom right, supporting national institutions. So I'll just give you a few minutes to read those through. And then I'll move on to the next slide. Another example here, you've got the 17 Sustainable Development Goals listed on the left-hand side. And you've got geology, geomorphology, soil and hydrology along the top with subcategories of each. And then boxes have been filled in to indicate how these two interact, the interaction of the geosciences with the Sustainable Development Goals. Now, but this is the publication that is most relevant to this topic, which is by Gill and Smith, 2021. It's called Geosciences and the Sustainable Development Goals. I'm not going to talk about all 17 goals. I'm going to pick out some examples. And there is a strong overlap between the goals, as you'll see. And unfortunately, the COVID-19 outbreak has made the achievement of many of these goals even more difficult than they would have been previously. Okay, so number one is no poverty. Now, poverty is often defined as a lack of resources needed to ensure dignity and survival. And the World Bank in 2015 estimated that there were 736 million people living in extreme poverty. And half the world's population, about 3.4 billion people, were living on less than $2,000 a year. And the impact of poverty is that it hinders people from reaching their full potential. It reduces life expectancy, it increases vulnerability to economic and environmental shocks, and it threatens access to essential facilities such as food, water, sanitation, shelter, healthcare, and education. And in addition to that, it's obvious that poor people will have little interest in the theme of this conference, or this set of lectures, which is geoheritage and national parks. Now, what role might geoscientists play in reducing poverty? Well, a main way is to identify natural resources that can be exploited. And that is a key skill of geoscientists. However, there are also geopolitical issues in this. And I've talked about the example of Afghanistan, which is a poor country, but it does have many natural resources. It has oil, coal, copper, gold, iron, and a huge diverse range of gemstones. And the fact is that few of these are being adequately exploited. So the reduction in poverty, the key to reducing poverty in Afghanistan is to better exploit these natural resources of the country. But an important aspect as well is that geoscientists and geoconservation experts need to balance the benefits of resource exploitation against their sustainable development and protection of geoheritage and the environment. Okay, number 2 is zero hunger. And like poverty, this one is strongly related to poverty. And hunger is concentrated in sub-Saharan Africa and Southern Asia, plus some pockets in South and Central America. And in 2017, there were 821 million undernourished people in the world, it's estimated. And that includes 151 million children with stunted growth under the age of 5, and an incredible 45% of child deaths were due to starvation. But the fact is that increasing life expectancy, population growth, and rising incomes mean that food demand is increasing as well. Now, the role of geoscientists could be in advising on soil, avoiding soil degradation, improving soil structure, retaining soil moisture, and the sustainable use of land, and so attempting to improve agricultural productivity and agricultural resilience to environmental change. And another important aspect is the availability of water for crop growth. So this aspect is tied to climate and water management. So again, geoscientists have a role to play here. And of particular relevance are programs like Land Care, developed in Australia, but used elsewhere, such as in Iceland, and nature-based solutions, such as the United Nations University Land Restoration Training Program. Number 3 is good health and well-being. The World Health Organization, the WHO, defines health as a state of complete mental and social well-being, and not merely an absence of disease. And it's clear that good health requires a nutritious diet and is therefore related to the first 2 SDGs on poverty and hunger. It also requires clean water, sanitation, good living conditions, and a healthy natural environment. And it also means an absence of exposure to toxins and infectious diseases, freedom from physical injury, and good access to healthcare. And obviously, COVID-19 has had an impact on the achievement of this goal. Geoscientists can help in understanding the origins and movement of pollutants through the environment. Now, there was a report published earlier this year by the World Health Organization that said that being out in nature is essential to improve physical and mental health. Nature provides opportunities for stress reduction, physical exercise, relaxation, and increased life satisfaction and happiness. And although this is often stressed as being related to the biological world, being out in forests or in woodland or in meadows or moorland, the fact is that being out in areas like the photograph here from the Austrian Alps, it's about the physical environment too, the mountains, the coasts, the rivers. Being beside these physical features is important to mental and physical health as well. And the establishment and management of national parks like the one in Austria shown here and other protected areas is a huge part of achieving this particular Sustainable Development Goal. Number 4, quality education. Now, access to education has been improving around the world, but there are still parts of the world where primary school-age children are not in school or where girls are denied the right to education. And I'm particularly thinking here of Afghanistan, where apart from parts of the northern part of the country, girls are being denied the access to education by the new Taliban regime. Geoscience education also instills important skills to achieve sustainable development, and these include aspects like spatial and temporal reasoning, systems thinking, interdisciplinary and collaborative problem solving, and the ability to cope with uncertainty and probability in dealing with complex systems and incomplete data. Geoscientists also understand issues of deep time, climate change, land management, and resource depletion. Geology and geoconservation are often not part of the school curricula, but geography around the world usually is and includes geoscience topics. In 2008, UNESCO launched an Earth Science in Africa initiative. The aim of this was to train up the next generation of geoscientists to take forward research in Africa. And this training included geological mapping, teaching geology in schools, and reducing the impacts of mining. Global geoparks have an important geoscience educational role, and also, as has been said, UNESCO has designated the 6th of October each year, starting in 2022, to be International Geodiversity Day, and this will also have potential for public education about geoscience. So I'm hoping that everyone watching this lecture will play a part in celebrating that particular geodiversity on that particular day. Number 6 is clean water and sanitation. Clean water and sanitation are essential for health and well-being. And where rainfall is low, geoscientists can make a major contribution in understanding the groundwater resource, what the abstraction rates are, rainfall patterns, groundwater recharge rates, climate change, and the potential for polluting activities, and whole catchment management and groundwater management. Number 7 is affordable and clean energy, and this particular SDG has the potential to contribute significantly to several other SDGs, because having a clean and affordable energy enables business, industry, agriculture, transport, communications, and healthcare to operate, and leads to increased living standards and well-being. And geoscientists can help here in identifying and designing systems to use nature-sensitive renewable energy sources, including geothermal energy. For example, Icelandic geoscientists are working in the East African Rift Valley to develop that geothermal resource. Geoscientists are also involved in the storage of radioactive waste underground and carbon capture and storage also underground. Number 8 is decent work and economic growth. Now, this SDG is strongly related to several others because decent, well-paid jobs prevent poverty and hunger and lead to healthier and more fulfilling lives. And geoscientists can contribute here by helping to identify and develop natural resources, including groundwater, minerals, hydrocarbons, and renewable resources. And of course, geotourism in protected and conserved areas, including geoparks, also supports local economies. Number 9 is industry, innovation, and infrastructure. And these three I's,
Recording stopped. Recording in progress.
These three I topics are important in delivering the jobs and economic growth of the previous SDG, decent work and economic growth. Energy supplies, water and waste infrastructure, fast telecommunications are all necessary. Geoscientists are involved in understanding ground conditions, availability of geomaterials, and the potential for geomorphological processes and hazards. Number 12, jumping, as I said, I'm not talking about all 17 of these SDGs. But number 12 is responsible consumption and productivity. Now, global demand for natural resources is increasing rapidly, and that's because economies and living standards are increasing across the world. Global use of natural materials tripled between 1977 and 2017 and reached a total of around 92 billion tons. So that's the amount of natural resource, both biological and geological. Over half of that, however, is low-cost construction aggregates, things like sand and gravel. And these materials are crucial in supporting local economies, especially in the developing world. So the emphasis on natural geological resources is often with things like metals and gemstones, but the low-cost construction aggregates are much more important to local economies. Geoscientists have a crucial role in identifying these materials, these mineral resources, promoting their sustainable use and reducing the environmental impact of mining, including protection of geoheritage. And the geoconservation community could take the lead in developing protocols for good working practice. And geoscientists also need to play a role in the transition to a circular economy. What's a circular economy? Well, it's one where the use of primary resources is minimized by the reuse and recycling of materials. And that has the added advantage of also minimizing the need to dispose of material as waste. So I think that geoscientists have a responsibility to provide expertise on how to use the Earth's resources more sustainably than at present. Number 13, climate action. Well, in a report published earlier this year, the International Panel on Climate Change had the following quote: "It is unequivocal that human influence has warmed the atmosphere, ocean, and land." And that strong statement is mirrored by several climate-induced disasters that have been in the news in recent years. And you've all seen the news of flooding, hurricanes, storms, and wildfires. Now, the two approaches used to address climate change are mitigation and adaptation. Mitigation refers to actions taken to reduce emissions of greenhouse gases to the atmosphere, and adaptation is the process of adjustment to the expected impacts of climate change. And these two approaches are complementary because mitigation makes adaptation both more likely and cheaper. Now, geoscientists have an unprecedented insight into climate and environmental change because they've studied this through 4.6 billion years of Earth history. So geoscientists are in a strong position to decouple the natural causes of climate change from the human causes of climate change. Geoscientists are also involved in developing the use of carbon capture and storage in subsurface rock reservoirs, in developing renewable energy sources, including geothermal energy, as I've said, and in understanding the impact of climate change on geomorphological processes, surface hazards, and protected sites and landscapes. And there is this Sendai framework on disaster risk reduction produced a few years ago, and that emphasizes that climate change is a major driver of natural hazards and promotes international cooperation and early warnings to reduce mortality, damage to infrastructure and property, and economic loss. Number 14 is called Life Below Water. It's called Life Below Water here, but that's a rather misleading title because the full title of SDG 14 is Conserve and Sustainably Use the Oceans, Seas and Marine Resources. So you can see it's not just about life below water. Now we know that the oceans cover over 70% of the planet and make up 95% of its water. So the oceans are of immense importance to the functioning of the planet. They are significantly biodiverse. They play a critical role in regulating the Earth's heat budget, and they absorb carbon dioxide from the atmosphere. And the ocean floors and the subsurface of the ocean floors are a source of many minerals, including oil, gas, and aggregates. But there are also a range of elements that are derived from, for example, polymetallic sulfides, cobalt-rich crusts, and manganese nodules. Protecting the oceans from pollution and degradation and promoting their sustainable use are of vital importance for humanity. But as we know, they've been deteriorating for many years, and we've all seen examples of overfishing, plastic and other pollution of the oceans, acidifications, and heating affecting coral reefs. And geoscientists also have a role to play in predicting future sea level rise and its effects on low-lying countries and communities, studying rates and causes of coastal erosion. You've got a slide here on the right of coastal erosion taking place very near where I live, advising on the extraction of seabed minerals, and campaigning for more marine protected areas for both biodiversity and geoheritage. And the final example is I'm going to describe is number 15, which is life on land. And the aim of this SDG, or the aims, are to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, halt and reverse land degradation, and halt biodiversity loss. Geoscientists can contribute to many of these aims, particularly those related to desertification and land degradation. In addition, they can play a key role in promoting what's called the conserving nature stage approach. And this is an approach that uses the metaphor of biodiversity being the actors, whose distribution is often largely dependent on the physical geodiversity of habitats, which represents the stage. So, for example, on the slide here, on the photograph here, it's from the West Coast National Park in South Africa, and so the stage here is the granite outcrop, and the actors are the plants growing in some sediment in a joint in the granite outcrop. So a wide range of habitats is needed to enable species to adjust their distributions, particularly in response to climate change. So you need those diversity of the physical habitats to allow the species to adjust their distributions in response to climate or other environmental change. Knowledge of geology, geomorphology, hydrology, and pedology can inform conservation and restoration programs, but requires better partnership working between geoscientists and ecologists, although this is starting to take place. Input from geoconservation experts can be helpful in the identification and management of protected areas. So, in conclusion, as I said at the beginning, the 17 Sustainable Development Goals present ambitious and challenging aims and targets, but they have the potential to transform the global community, giving all people dignity, equality, and the resources they need to lead healthy and successful lives in a sustainable global environment. And the geoscientists, as I hope I've demonstrated in this talk, have an important role to play in achieving the Sustainable Development Goals. But many hurdles remain. Monitoring so far suggests that in some regions we're at least decades away from achieving some of these SDGs. And I believe the developed world needs to step up to provide resources and expertise. And of particular importance to the geosciences is a particular charity, which is called the Geology for Global Development Charity. And this provides opportunities for geoscientists to develop their skills and capacity to deliver the Sustainable Development Goals. So it's an important organization. Geoscientists can provide input in the identification, development, and management of protected and conserved areas. And they can also provide the double benefits of conserving natural features and processes, while at the same time providing security of the basic resources of life for the more disadvantaged communities to help improve their lifestyle and life chances. And this is why the United Nations devised these 17 Sustainable Development Goals and why they are being implemented. Thank you very much.
Thank you very much, Professor Green. It's really good. And it's very good we have some more time to ask questions. So question time now.
Okay, I'm happy to answer questions on this or the wider field of geoheritage, geoconservation, and geodiversity.
First of all, could you help to introduce the initiative about Geodiversity Day, and how did you and your colleagues to initiate this this activity, and how did it have been approved by UNESCO?
You want me to talk about
the story? Behind it.
Well, it started in 2020, May 2020. Mm-hmm. So over 18 months ago, I noticed that I can't remember the date in May, but there is an International Biodiversity Day. And I noticed that and thought to myself, well, if there's an International Biodiversity Day, why can't there be an International Geodiversity Day? And I wasn't the only one who noticed that. And so three of us, myself, Josie Brilia, and Professor Zwolinski from Poland, had all noticed it. And we exchanged emails and said, why don't we go for this? And about the same time, there was this conference coming up at Oxford, or organized by Oxford, by Jack Matthews. And we decided to float the idea at that conference. And there was a lot of support for it. So we then started moving forward, trying to get as many geological organizations around the world to write letters of support for it, and we got over 100 letters. We sent those off to the IUGS, because it's affiliated to UNESCO, and we asked it to support this idea and to send the letters to UNESCO, which they did. And UNESCO was very interested in the idea. The earth scientists working at UNESCO were interested in the idea, and we started working with them. And we got, in the end, 75 countries to support it, including China.
Oh, 75. Wow, that's a big number.
75 countries supported it, and it went through unanimously through the executive board and then through the general meeting of UNESCO. just last month.
Wow, that's also very big workload. I mean, there's 75 countries. So do you have a secretary to help you to do that?
No, the earth scientists at UNESCO really did a lot of the work for us in contacting countries and trying to get support.
Yes.
So that took a huge amount of work, as you say. But we were not too much involved in that, except that we lobbied geologists in the various countries to contact their commissions to UNESCO to support the idea. So that was very successful. Yeah.
I also have a suggestion. Could you be the guest chief editor for the special issue on Geodiversity Day? I mean, can invite some, the experts who contribute a lot for this initiative, and read 6 to 8 articles for International Journal of Geoheritage and Parks, and let more people to know about the background and the stories behind it, and also the scientific background about that. So I think it will be very interesting thing. If you could consider that, that couldn't be better.
Okay, well, we are going to write some articles,
Great.
but we haven't decided exactly where at the moment, but we are intending to do that.
Okay.
I'll need to talk to my colleagues.
Okay, great. We will contact you soon later about that. Thanks. Okay, more questions here, I think, right? Okay, yeah, Professor, Jin Yang, Dr. Yang, yeah.
I have a question for Murray. I think undoubtedly geoscientists are very important to achieve the SDG that you just mentioned in details. But what I'm worried right now is since the reality around the world, it's our university are having problems in actually attracting students to study geoscience. Like subjects like geologies and geography, I think a lot of universities around the world actually have the problem of recruiting students. So what do you think that we should do in order to attract more students in studying geoscience, and so that they can play a bit more roles in achieving that SDG?
Well, I think one of the things that we can do, particularly in geology, I would say, is to get involved or try and attract more students in topics like climate change, because young people are very interested. A lot of young people are really interested in climate change. And as I said in my talk, geoscientists are expert in climate change, are they not? Because they've been studying climate change and the effect climate has on the environment more generally. So that's one aspect. But I think lobbying to get more geology taught in school is an issue, because I don't know what it's like in where you are, Young, but as I said in my talk, geology is often not in the school curriculum, which is ridiculous in my view.
It's actually have been a lot of universities, they even downsize the program or curriculums, and maybe because of the very low number of intake of students. So that's what I'm worrying, because as you said, we need a lot of geoscientists in the coming years, but we have decreasing number of students. So that's really causing a lot of problem. And where I'm located right now, I'm in Sydney, Australia, and we do have the same problem around basically all the universities here. Yeah, I'm not sure whether you have the same problem in UK.
Yes, we do. Yes. But as I say, I think the solution lies in trying to explain the importance of the geosciences to be taught in schools, and that will be done through things like teaching these crucial issues of the day, like climate change, land management. These are crucial to the Sustainable Development Goals, to the future of humanity, to reducing hunger and poverty, and so on. These are all topics that young people are interested in, and I think that we need to make a better case to get these subjects into the school curriculum, and then they'll come through to the universities. But unless we do that, I don't think it's going to get any better.
Yeah, I agree.
Okay, thank you very much. Yes, it's a really good question and very nice answer. Okay, any more question here?
Can you tell me what the position in China is in relation to teaching of geology and the geosciences in schools?
You mean Yang or me?
No, you. Sorry, you.
Oh, okay. I'm teaching in Faculty of Geographical Science of Beijing Normal University, and well, we about the geoheritage. As I'm the chief editor for the International Journal of Geoheritage and Parks. This is a journal of Beijing Normal University. So we just did a lot of program, with the journals, like these conferences, and we also have some programs, related to the national parks and protected areas, mainly focused on the nature education, interpretation, and ecotourism. Yeah.
I was asking about in schools. Is geology taught in schools in China?
In Beijing Normal University, we don't have a geology major. It's in China Geoscience University of Geoscience, Beijing, and several other universities. And they have. Yeah.
No, I'm not talking about universities. I'm talking about school level. Primary school.
Primary school. Okay. So
school level.
For the school level, we the geology was combined with geography. We have the geography courses for the junior, middle school, and high schools, and we are also the authors for the geography textbooks for junior, middle school, and high schools, it has different versions, and geology is a part of this content. So it's and also it's a combination of nature geography and human geography together. Not like in the United States, they divide into the human geography into social science, and nature geography into earth science. But we combine together. So geography is quite strong here, and we also, for the junior, middle school, and high school students, we also have the competition. For the high school students, has the geography Olympiad. For the winners, they also participate in the International Geographical Olympiad that's hosted by the International Geographical Union.
Mm-hmm.
Yeah.
Correct.
So I'm thinking, we will have another competition collaborate with EBSCO, combine the GIS and remote sensing technology. So I'm thinking, later the geoheritage, protect areas, and this GIS or remote sensing tools, and geography, geology, or have how to say, all these elements combined together to have competition. These elements should be appeared in the this Olympiad. So in China, we host we publish the all the questionnaires was issued by the by our center. So each year this also have a big influence on that. So that's basic information. Okay. So how about that in UK? I know it is traditional, very strong, in UK school for primary and middle schools for geography. I don't know. It's still pay a lot of attention to that, right?
Yeah, geography is a popular subject in schools in the UK. But I would say that physical geography has declined. The teaching of physical geography in schools in the school curriculum has declined in recent years. But what has come in instead are some of the environmental issues.
Okay. Yes. What I want to say is, for many programs, the teach students in a smaller scope or scale. But in our experience, if we teach students in a bigger scope, like from the geomorphology, or even bigger, it can really help students to have a bigger eyesight on the Earth or on our planet, and then they go to a smaller scope or a scale and make them to know this world better. It's from our experience, it's very very useful experience for that. So for now, for the geomorphology and for talking about geology, they are more focused on the stones, rocks, but that's not only for that for today. So the big professors like you, should more give more talks about that, and then more people to get to know about this concept more precisely. So I think this is very useful, and more articles should be written by these big professors. So a lot of work to do, right?
Yes, sure.
Okay, Dr. Li, do you have a question?
Yes. Hello, Marie. I have a question. So before listening to your presentation, I read your article from your article, Geodiversity, Geoheritage, and Geoconservation from Society in International Journal of Geoheritage and Parks. So I have a question about the definition of geodiversity. So I having read your paper, I think you prefer the definition is that the natural range diversity of geological rocks, minerals, and geomorphological and hydrological features. So these three features are embedded in geodiversity. So geotourism, also has three elements, which are abiotic, biotic, and cultural elements. So I want to ask you a question about the definition of geodiversity. In geotourism, A is mainly accounted for 30%, which acts with biotic and cultural. So I I have a question about the definition of geodiversity. Do you think what is the relationship between the geodiversity and the geotourism, or do you think the geodiversity can three elements can also interact with the culture or a biotic?
Right. Okay. Well, my definition of geodiversity simply describes the variety of the physical features of the planet. Yes, those physical features. Those physical features are then, if you like, available for uses like geotourism. So I wouldn't put geotourism into a definition of geodiversity, but geodiversity leads to geotourism because people like to visit different places. Yes?
Yes,
people like to visit. If the world was all the same, there would be no point in going anywhere. It's the diversity of the physical environment of the earth that leads people to want to go to see different physical places. But as you say, that's often combined with ecotourism and cultural tourism. You know, the three things are often interlinked.
Yeah.
Does that answer your question?
Yes. Yeah.
Okay.
Yeah.
Very good. Thank you. Any more questions here? Dr. Du Yi. Do you have a question?
Hi.
Yeah.
I might have a question, but my camera doesn't work, so I'm despairing in my virtual background. I'm thinking about the question. Well, Professor Gray, thank you for your presentation. And you mentioned about the initiative of geodiversity was raised in the same inspiration of similar inspiration of biodiversity. And in terms of biodiversity, I'm curious about, I work on the cultural diversity and its relationship with the geoheritage. So what do you think about this interrelations of geodiversity and cultural diversity? Do you have any comment or ideas about what place of human and cultural diversity in this concept of geodiversity? Do you think it's yes, thank you.
They're obviously linked because I mean, geotourism, for example, tourism is a cultural activity, and something else that comes to mind is that the physical environment often inspires artists, musicians, sculptors, poets to create many of their works. You know, they're inspired by the natural world, including the geodiversity of the world. And then you've got the field of archaeology, which shows the interrelationship of people with the environment going back through time. So they're all interlinked. Geodiversity, biodiversity, and cultural diversity are simply all interlinked.
Okay, very good.
Okay, thank you very much. And perhaps another question. Professor Gray, you mentioned about this issue of climate change, and this I do agree that this is quite important in terms of geodiversity and geoscience in our society. But I have noticed that usually a phenomenon that scientists are sometimes, in terms of this cultural, social debate related to climate change, scientists usually tend to be more take a distance, that try not to engage in this political discussion and debate. And with this geodiversity and geoscience in society, I think in the future, with the debate is becoming more and more heated, and scientists need to make a choice whether to be more engaged in this societal discussion or try to stay focused on the science itself. And what I don't know, what's your opinion on this this choice of scientists?
Well, I suppose I'm probably a bit of a traditionalist in that I think scientists should do science and leave the politics to politicians and the public. But scientists, in my view, should stick to doing the science, and how that's then taken forward is a matter of personal judgment. Some scientists will want to get involved in the political process, and others won't.
Okay.
Okay.
Thank you. Thank you.
Okay, thank you, Dr. Du. We have a last question, which is very big in our chat box. And this is from Cai Shenping. The geoscientists can make great contribution to the SDGs, but how? In Professor Green's presentation, you already see some, and I think more details, we can maybe read from Professor Marin's the papers maybe will be published in International Journal of Geoheritage and Parks. So yeah, that's a lot of things to say. So do you want to maybe write later, or just want to respond a little bit, Professor Green? Yeah.
If anyone's interested in getting involved in helping with the SDGs, the best thing you can do probably is to go on to the website of that organization I mentioned, Geology for Global Development. Yes, Geology for Global Development. Yeah. And follow the steps that they suggest. Yeah. Yeah, so they have suggestions on the website. Yeah. This Mr. Cai can maybe follow up this and read more. And if you have more questions, welcome to write to Professor Maureen Green, or talk with her. Thanks. Yeah. Thanks. Thank you all your questions. Especially thank you, Maureen, for your excellent presentation. Really learn a lot, and it's a really big think very productive presentation. So we are so at last I want to thank you, and also invite you, maybe next time we can meet in time, maybe in China or some places. We will have a session next July in Paris, France, about the heritage, and hope you can join us then in July in Paris, and also all the audience, and also we send invitation to all of you, and if you have time, welcome to join us then for another big event. Okay.
Hey, Dr.
Thank you.
Take a photo.
My pleasure.
Before.
Okay, could you please open all your video and take a picture? Thank you.
So, Professor Greg, can you stop sharing the screen so I can take the...
Okay, could you all open your video for all the audience?
Sorry, I think my video is open.
Yeah, I'm not talking to you. I mean, for the audience.
Oh, sorry.
Okay.
Wait a minute. Sorry. Okay, done. Thank you. Okay, I finished. Thank you.
Okay, thank you all. Thank you. Thank you, Maureen.
Bye.
Talk to you later. Talk to you later. Bye.
Bye.
Bye all. Bye. 杜毅. Okay. 郑阳. Okay. Bye.